Hello again, everybody. So we're going to continue for the second week with a little bit more review, try to catch ourselves up with some of the Regents or some of the topics that we've gone over earlier in the year to help us kind of prep for the Regents a little bit earlier than normal. So today we're going to focus on triangle problems, quadrilateral problems, and basically all of our missing angle problems. They could be parallel lines and stuff like that. In the first one, in the diagram below, line FAD is parallel to line EHC, and line ABH and BC are drawn. If the measure of angle FAB is 48 degrees and ECB is 18, what is the measure of angle ABC? So remember, when we are talking about three-lettered angles, we're really talking about what letter is in the middle. So FAB is 48, ECB is going to be 18, and again, we want to know the measure of angle ABC. So if we take a look here, what we have is a couple different things. One, they told us that FAD and EHC are parallel. So that means 48, and we can go 48 here. Those are alternate interior angles. And then from there, there's a couple different ways to go. You could follow the fact that triangles add to 180 degrees and then do supplements to get X. Or you could do your exterior angle rule, which is what I'm going to follow here, which says the exterior angle X is equal to the two non-adjacent interior angles added together. So in this case, X is going to be equal to the 48 plus the 18, which in this case is going to give us 66 degrees. So that's definitely one way you could go about this problem. Again, if you were going to do the supplementary piece like we had up here, you would do 48 plus 18 is 66. 180 minus 66 would give you 114. So that would go here. And then you would basically be in the 180 minus 114 game because it's supplementary, which would then give you back to your 66 degrees. So either way is fine. It's kind of up to you which way you want to go about it. In the next one, in quadrilateral QRST, diagonals QS and RT intersect at M, which statement would always prove that it is a parallelogram? So you got to remember, what are our properties of parallelograms, and sometimes it helps to draw the picture. And remember, you always label in some sort of circular fashion here. So if we remember, TQR and QRS are supplementary. Well, that just says there's one set of supplementary angles. You don't know if that's true or not for all of them, so therefore that doesn't really help us. So if we list out our properties here, that actually might be a better way to go about it. We have both opposite sides parallel. We have both opposite sides congruent. We have opposite angles are congruent. We have adjacent angles are supplementary, and again, that's all of them. This is only an example of one of them, though. And then our last one I'll put up top here is the diagonals bisect each other. All right, so those are our 5 properties. And remember, there was that hidden property that had one set of sides both congruent and parallel. Okay, so a lot of our stuff spoke here about both sets of sides parallel, both sets of sides congruent, but if you can get one set of sides to be both congruent and parallel, then that's going to be your answer. So if we look here, TQR and QRS are supplementary. Again, that's only one set. It doesn't prove that they all are. QM is congruent to SM, and QT is congruent to RS. Well, that talks about one set of diagonals and one set of sides, so we know that's wrong. QR is congruent to TS, and QT is congruent to RS. Well, that looks like both sets of opposite sides are congruent, so we'll hold on to that one. And then QR and TS, and then QT is parallel to RS. This is the one they always try to trick you on. Whenever it's one set of sides congruent and the other parallel, that's a trapezoid. So the only one that works here is choice C. So you got to remember that hidden rule for part D is that it's the same set of sides. So one or the same set of sides, both congruent and parallel. A quadrilateral must be a parallelogram if, and this really goes off the same thing, one pair of sides is parallel and one pair of angles is congruent. We know that's not it. One pair of sides is congruent and one pair of angles is congruent. That's not it. One pair of sides is both congruent and parallel. That looks like our hidden one. And the diagonals are congruent. That doesn't help us. So our winner there is choice C. In rhombus TIGE, diagonals TG and IE intersect at R. The perimeter of TIG is 68 and TG is 16. So there's a couple things here. If the perimeter is 68, we know all sides are congruent. So 68 divided by 4 is going to give us 17. So we know that all the sides here are 17. The next thing is this. The fact that TG is 16, well, we have to remember our carryover property from parallelograms, that the diagonals bisect each other. So that really gives us 8 and 8. Ultimately, what they want us to find out is they want us to find the entire length of IE, but I'm going to find IR first. And the way we do that is because the diagonals are also perpendicular, we get right angles in there. So really we end up needing to be able to do Pythagorean theorem. So we get x squared plus 8 squared equals 17 squared. X squared plus 64 equals, and then if we bring up our calculator here, 17 squared is 289. Subtract the 64 on both sides. X squared equals 225. We'll square root both sides. And x is 15, which of course is an answer, but remember, that's what IR is equal to. If we want the whole length of IE, we have to make sure we multiply it by 2, and we get that IE is 30. And number 5, in parallel PQRS, QP is extended to T and ST is drawn. If ST and SP are congruent and the measure of angle R is 130 degrees, what's the measure of angle PST? Well, a couple things first. We've got an isosceles triangle. All right, we've got our two congruent sides. Here, I can put a 130 degree angle because we know that opposite angles are congruent in a parallelogram. If I use supplementary angles here, I end up with 180 minus 130 giving me 50. And then again, these are my two congruent base angles of my isosceles triangle. So therefore, if I know angle SPT is 50, I know angle PST is also 50. All right, so remember, that isosceles triangle piece is kind of key to getting us to know that we have our two congruent base angles. In the diagram below of triangle ABC, AC is extended through point C to D, and BE is drawn to AC. Which equation is always true? So if we take a look, 1 on the outside is equal to 3 plus 2. Well, that looks a little bit like the exterior angle rule, but the problem is angle 2. Remember, it's non-adjacent interior angles. Angle 5 is equal to angle 3 minus angle 2. Well, I don't really know about that one. It doesn't seem like they're really connected that much. They're part of different triangles and semi a part of the same triangle because angle 3 is not really all of angle B. See, angle 6 is 3 minus 2. That's kind of the same thing. They don't really connect in any way. The last one, choice D, angle 7 is congruent to angle 3 plus 2, and that right there is our exterior angle rule, which states 7 is the exterior angle here of that triangle. Angle 3, because now if we draw it, imagine we drew that one triangle there without the additional one. You can see that 7 is the exterior angle, 3 and 2 are the non-adjacent interior angles, and then therefore you have your exterior angle rule. In 7, in the diagram of quadrilateral navy below, it gives you a whole bunch of angle measures, and it says which one is the shortest length. So you got to remember the rule, which is shortest side is opposite smallest angle. So shortest side or smallest side is opposite your smallest angle. So let's start to fill in some missing angles here. So if we look at our little triangle, we have 94 and 46. So 94 plus 46, we'll subtract it from 180 and we get a 40-degree angle here. And then here, 30 plus 38 and 180 minus that, not 78, 68 is going to give us 112. So we got a 112-degree angle here. So if we look, we've got in this small triangle here, if we go in order of sides, based on the fact that the smallest side is opposite the smallest angle, it should be AV is less than YV, which is less than AY, because the 40-degree angle is the smallest, so AV is the smallest, 46 is in the middle, so YV is in the middle, and then obviously the biggest one is AY opposite the 94. If we go into our big triangle here, it would be AY, because it's opposite the 30, is less than NY, because it's opposite the 36, which is less than NA. So out of all of these, which is going to be our overall smallest side? Well, if we look here, VA or AV is the smallest side of the smaller triangle. So therefore, that is going to end up being our smallest side overall. Because obviously all the sides in this piece are bigger here. This is our smaller triangle, so what's the smallest side of the smallest triangle is going to be VA. In number 8, BD is the perpendicular bisector of line ADC. Based upon this information, what can be proven? So if we have ADC, and let's make a better line here. So if we have line A, and we'll put point D in the middle, right? And it told us it's the perpendicular bisector, so we know we've got right angles there. Which of these can be proven? Well, BD is the median. That is true, okay? Because obviously, D is the midpoint if it's going to be the perpendicular bisector, so that right there is going to be a true statement. BD bisects angle ABC. So if we were to connect and kind of make this into a triangle, that is also going to be a true statement. BD is going to be the bisector there of angle ABC, and the reason that's true is because this last piece is true. Triangle ABC is isosceles, all right? If you have the perpendicular bisector to a side like that, that only occurs in an isosceles triangle, so what's going to be our correct answer here is going to be choice D, all three of them. In triangle XYZ shown below, we have medians. Now, when you have three medians connect, that's the centroid, and we should remember our 2-to-1 ratio, which says that the part coming out of the side, so like XC, is twice the length of the part, the part coming out of the angle, XC, is twice the length of the part coming out of the side, CE. So in this case, if CE is 5, we know that XC needs to be 10. If YF in total is 21, we need to break it up into 3 parts, which in this case is 14 and 7. 7 is the smaller part. YC, 14, needs to be double that. If XZ is going to be 15, then that means, again, if they're all medians, it's cutting them in half in this case on the outside, so each of those is 7.5. Determine and state the perimeter of triangle CFX. Well, if you add all those up, you end up with 10 plus 7 plus 7.5, which gives you a perimeter of 24.5. And our last one, in parallelogram ABCD shown below, the bisectors of angle ABC and DCB meet at E. If angle A is 68 degrees, determine and state the measure of angle BEC. Since opposite angles are congruent, we know that this is 68, which means when you cut it in half, you get 34 and 34. This angle up here is supplementary, so we know it is 112, which when you cut in half is 56 and 56. Then, if we take our last piece here, and then we're going to add these two together. So 56 plus 34 gives us 90. So then 180 minus 90 gives us a 90-degree angle for x.